Welcome back. Today's topic is integrity rules. Data integrity has 4 types: domain integrity, entity integrity, referential, and semantic integrity. For domain integrity, our attributes must fall under particular range in order to be valid. Think of having age attribute where the value is 0 or -1. So that will be direct violation of domain integrity. Entity integrity will ensure that set of attributes cannot have duplicate values or null values, and those are primary keys. Referential integrity ensure that the value of foreign key in the referencing relation must exist. Semantic integrity ensure that data in our database is logically consistent with respect to the real world. Here's 2 examples of semantic integrity. Number of pages of a book cannot be 0, or author cannot review their own book. So let's recall for entity integrity, each entity has unique key and it cannot be empty. Referential integrity, we need to ensure we have foreign key which can be null or will match primary key in a related table, but it cannot contain any value that does not exist in the related table. Table on the right, departmental code is primary key. It's unique. It cannot be null. Table on the left contain department code as foreign key. So the value correspond to values from a related table, but that value can also be null. Entity in our database can have different types of relationships. We already know that we have relation between primary key and foreign key, but the relation can be also one-to-one, one-to-many, or many-to-many. Let's look at one-to-one relationship. The type can be due to improper data modeling, or it can be used also to represent entity with uncommon attributes. One-to-many is the most common relationship in relational database modeling. And primary key of 1 will be foreign key to many. Many to many is a different type of relationship and should not be represented in relational database directly. And it should be implemented by breaking it into a set of one-to-many relationship, which are, as we mentioned, the most common relationship. So we should be creating a sort of composite bridge entity. This is an example of many-to-many conversion to one-to-many. All right, so in the first table, we have student data that also have attribute of class IDs. What happened is that one student can take many classes. In one class, many students can be enrolled. How can we break that into composite tables or smaller tables? If we represent student ID and student name as one table, and bridge it to class table where student ID will be a foreign key and class ID will be primary key. All right, so those tables should contain at least a primary key of original table. For foreign key, we can have multiple occurrences, but at least in this way, now we can have a non-duplicate student ID that we can relate to class IDs. So what you see on the left are representation for entity relational diagrams. The first model, crow's foot diagram, represent entity as boxes and relationships aligned between boxes. And we have different shapes and different relationships. I would like us to look at history of this type of notation and dive into more details on entities and relationships representation. So back in 1976, this type of notation was introduced and was referred to as arrow because of that symbol, a line pointing from one entity to another one with some sort of fork. So an individual X can relate to multiple Ys, which is kind of interesting because it has some symbolic representation or similarity to a bird foot representation. So first we have entities, right? A class of object. We have a person, place, and it's represented as a rectangle with its name in the top. Please note that name in this representation has to be singular rather than plural. Then we have attributes that are property describing our entity. They are placed inside the box, and usually the unique identifier is marked with an asterisk. Relationships are illustrated using lines, and those lines have indicators. So you may find indicator with the perpendicular lines or 3 lines at the end. The relationship can be mandatory, which is shown by just 1 bar, or can be optional with a small circle. To summarize, the multiplicity of 1 in mandatory relationship is represented by straight line perpendicular to the relation line. So multiplicity of many represented by this symbol, right? Famous crow foot symbol. An optional relationship represented just by empty circle. And we have 4 possible edges in our relationships. We have 0 to many. Here's 0 and many. We have 1 to many. 1 and only 1. Notice we have 2 bars only. And 0 or 1. Okay, here's a better example. So we have a students and enrollment. There's 1 student and 1 enrollment for that student in the course. 1 to many, we have 1 lecturer and many courses, optional courses. And course can be taught by 1 lecturer, right? And many to many students can attend many courses, and many courses can be, in many courses, many students can be enrolled. So this is similar representation in MySQL Workbench, where you see those 1 to many, 1 to 1 relationship. All right, the second model is Chen model. And Chen was one of the pioneers of using entity relationship concept for information system modeling design. And Chen entity relationship notation is still used. Let's look in more details on this notation. So we have entities. The difference is we have different types of entities. We have weak entities represented by double lines inside the square, inside the box. So existence of weak entity dependent upon another entity. We have associate entities that use in many-to-many relationship. And attributes are represented by this oval shape with the name of attribute. So for instance, the movie entity have that many attributes. And the key attribute is underscored. Remember in crow foot representation, for the key we used asterisk, here we're using underscore. We may also have a partial key attribute that is combined with another key attribute. And we may have multi-value attribute where there could be many values entered in the same column. For example, hobby, right? We can have different or several different hobbies and consider as a multi-value attribute. Finally, derived attributes is used in this notation. Those attributes may not be physically stored in a database. Think of any derived calculation metrics. Attributes can have a composite attribute. The address can consist of multiple smaller parts. And relationships are represented as a diamond with the 2 kinds of relationship that we distinguish. Strong relationship is independent of other entities, and weak relationship where entity is dependent on some parent. All right, and mandatory relationship represented with solid line, and there's optional relationship with a dashed line. Here, for instance, in diagram, we have dashed line, optional, and solid line. So for data integrity, we need to look for redundancy. Is our redundancy uncontrolled, unnecessary, just repeated attribute value in the table? And the proper use of foreign keys can reduce redundancy. Controlled redundancy, on the other hand, is actually built from shared attributes in multiple tables. When we create foreign keys do not have to be unique. It is possible that foreign key will be duplicated. You have to be careful with the null values. What is null? We have no data entry. It could be non-existent data, for instance. There's a form for first name, last name, and middle initial, but what if you don't have middle initial? There's unknown attribute value, or known but missing attribute value. Data had not been collected for the specific subject, for instance. This all can create problems, especially when you use function to count or average or sum over data. And of course, the null value is not permitted in primary keys. Indices, it's one of the features that can make our retrieval of data faster. Okay, so we have a data with actor names and his relation with movies, movie names, and actor IDs. Let's say we know that every day we'll be using the same query. Let's say actor ID, querying the actor's name, referring to the movie that they played. So instead of running query through all the strings and chars, we may create an index table with its pointers that will point to second table. Of course, each index will be associated just with one table. But let's look at the first actor name with actor ID 12. So by using foreign key, we identify that movie ID for this actor is 231. So the actor ID 12 is associated with the first record in the movie ID, in the movies table. The second actor is associated with row number 2 and row number 5. And this is what we create in our index table, index key, and the pointers to specific records of the other table, just to facilitate data retrieval. All right, and finally, let's talk about data dictionary and schemas. So data dictionary is detailed description of our model, which should list attributes and characteristics, and also identification of primary and foreign keys. And it gives you sort of blueprint of your database documentation that allow others to replicate or for you to document any changes. Relational schema is visualization of our database structure. It will show entities and relationships. So we'll see tables and attributes. We'll see the types of relationships, which ones are linked. Here's example. Let's say a store entity is linked to payment entity, and store ID is primary key, payment ID is primary key. And each table has description when it's possible, comments, data type, etc. So this is example for data dictionary. We have a table name, attributes name, content, type, format, range, whether it's required or not, whether it's primary key, and additional comments, useful comments. Some data dictionary can be generated automatically. All right, that's it for now. See you soon.